Hey, in this recording, we will learn how to use Kangaroo in order to generate a mesh that can be unrolled into developable strips and then lay out those strips as flat pieces for potential manufacturing. So here are the steps of the tutorial. We will start by building a surface, polysurface on Rhino, importing it into Grasshopper, constructing a mesh from it, and then refining the strips in one direction, setting up the goal objects that will make those strips developable, plug them into a Kangaroo solver that will relax the mesh into a new state, from which we will unroll developable strips and lay them out. So let's first make sure that in your displays you have preview mesh edges on, and then we'll go to Rhino for building the surface. Let's start with a rectangle. Follow me here. Uh, from the center, maybe in XZ, let's make it a square of 10 by 10. Now we extrude curve in both sides and not as a solid. Let's say 30. We rotate it with project on in XZ 45 degrees, and then we mirror it in XY mirror from the center, also with an angle of 45 as a copy. So we have two intersecting surfaces with non-overlapping surfaces, but we want to make them into one polysurface, continuous polysurface. So we Boolean union. Okay, now it's one object. Let's make it a bit less rigid, play around with it a bit. So with Shift and Control pressed, we select an edge. Here you can change it as you wish. Bear in mind that this is not the final shape, but it's the shape that will be plugged into the Kangaroo solver. So we just wanna make it non-symmetrical. So here we go, maybe select some points. And we're good to go. Here we go back to Grasshopper. Now this is a brep. We import it as a brep. Alright, we hide it from now. And we know that Kangaroo does not work with surfaces. It works with meshes, with vertices, with lines. So we want to convert this brep into a mesh, except that automatically Rhino creates kind of messy faces for that mesh. What we want is every surface here of this polysurface to become a face of the mesh. So we will have to construct the mesh manually. So here, construct mesh, we see that a mesh is constructed from vertices here and from an order of these vertices here in faces. So we will have to take the edges of every polygon around the surface. So we deconstruct the brep. Okay, we take the brep edges of every face, and from here we take the naked edges and we join them with join curves. Now we explode the polygon we got, and here if we look into vertices, we will see that we have 5 vertices for each polygon. It's because it's a closed polygon and we have to call, and the last one is the same as the first one, so we have to call it, call index in integer, we put -1. Okay, so here when I plug those into a mesh, I have a perfectly clean mesh. Here we go. This was step 1 of this tutorial. We move into refining the strips. Okay, now this is multiple meshes. So we flatten them, we join them, and we weld them. We weld the mesh. It means for every two intersecting faces, we end up with one edge and not two. So add to group. All right. Now we refine this mesh. So we subdivide its faces with a certain level. Here we're deciding on the width of the strips. So let's say level 2. This is the width of every strip. So 3 would give us very thin strips. 2 is good. We combine and clear. And so now we've divided the mesh, but we're not sure if Grasshopper by default took the strips in the transverse direction or in the longitudinal direction. So the transverse direction would mean every side of this cross would become an independent piece that will just be glued to the other side. What we want is these longitudinal strips that will go from one side to the other. So in order to unroll this mesh and see which strips it's chosen, we will use the component stripper and then the unroller. Here we go. Now, as you can see here, it took those transverse strips, and that is exactly what we do not want. So what we'll do now is we'll change the direction of the mesh direction here, and now we can see if we put here one in the unroller and unroll it slowly, we'll see that it's chosen those strips, the longitudinal ones. Okay, so we're good to go, but we don't need those for the moment. We'll unroll once we've relaxed it in Kangaroo. So now we have to refine the strips themselves. So as if we're adding divisions, but in only one direction. So we'll use the refine strips here. And let's say 2 as well. Maybe more, 3 is good. No, 4 is too much. 3 is good. Okay, so this was step 2 of this tutorial. Now we need to set the goal objects of the Kangaroo relaxation. So here I've done another list. So as you know, for a relaxation to work, you give it goals or rules, and to each goal you will give a strength. As so, how important it is for this goal to reach its optimum. So the main goal is to planarize every face of the strip, this is what will make the strip developable. So unrolling a strip would mean folding every side of this refined strip as a movement of rotation, just like unfolding a paper. So this would have a very high strength. Now, the shape itself, in order to like keep it in place, we're gonna fix the boundaries. So as if the points are acting as anchors, and then let it all hang in tension. So each line, each edge of this mesh will give it a goal of a length 0. So it's gonna try to stretch, but we'll give that a strength very low in order for it not to actually reach 0. And for the strips to have more or less equal sizes, we will equalize the edge length of every strip. It will become clearer when we go through it. Let's start by planarizing. No. Sorry. Okay, this one. Planarize the mesh with a strength of 100. Now we want to change the length of every edge. Since the edges are disproportionate, so we have long edges and short edges for every face, we're gonna divide the two types of edges. So use the warp weft component. Here it's joining every two opposite sides of every face. So here we can see we have the long edges and here the short edges. So for the long edges, we'll put the component length of kangaroo and give it a length of 0 and a strength of 0.15, let's say. So, and for the short ones, we can increase the strength because they're very short compared to the other ones. So let's say 50 times 50. Here we go. And now for the third goal, it's the length of edge. The second goal is to fix the boundaries. So in order to get those boundaries, we have to use the component mesh edges and take the naked edges, so E1 here, and join them. So join curves. You see here in E1, we have those edges here. So maybe we can change their geometry a bit, fit them into a circle, so it's a smoother mesh. First, we have to take the points of this curve, not the lines, so we explode it. We get the vertices, and just like it was with the here when we here when we call the last index, we're gonna do the same here since it's a closed curve. So -1. So now we've selected every point. We fit a circle between these points. Circle fit. Here you go. And now with the component onCurve, which is also a kangaroo goal object, the solver will try to fit the points on these circles. And here too we'll have a strength of 100. All right. The last one is here, the edge length. So here the segments will try to equalize their length. So equal length. The lines are the segments and the strength is 1. Okay. Now that we've had our goal objects, we can put our solver. Make sure it's off and give it a reset button. Here you probably know the component show, which lets you output whatever you've inputted into the grasshopper. So what we want is to output the mesh, and we entwine everything. So we'll put the mesh in the first branch and all of the goal objects in the second branch, and plug it into goal objects. So the output now, if we explode tree, in the first branch we have a mesh. Let's turn off everything and see how this will react. So true. Okay, so we can see that here the strength of the length 0 is very high. It's actually, we've made a mistake here. It's B that needs to be plugged in length. And now we reset and we see it react actually. This is more or less nice. We can maybe decrease this. And we wait until it converges. Now that it's converged, we can start unrolling. First, let's put a data done after the relaxation in order for everything that comes after not to reiterate if we were to play the solver again, which would make Grasshopper crash. So we play it, and this is our new mesh. Just like we've done before, we will use the stripper and followed by the unroller. Here we go. Now these are our strips, which are flat. So now in the next step, we'll try to find the plane of every strip, since every strip is flat and just projected on its own plane, and project that plane on X and Y plane and move each strip a bit further apart from the other by the width of the preceding one. So in order to find that plane, we have to get the axes on which every plane is standing. So we'll take the vector from the first face to the last face of every strip. So we explode the mesh, and then with list item, we select the first, and here when we zoom in and plus, we select the last. And with face mesh, face normal, sorry, we will find the center of each face. So now we can have a vector to point from the first to the last, and a plane normal of the last face, which we will align as per this vector. Okay, now this is the plane on which the current strip is laying. Now we'll find the bounding box of every strip in that plane. So here, if we just plug it, it will find the bounding box in plane XY. What we want to do is find it in this plane. So Okay, make sure you've grafted them so that here you can see every plane is lying on the surface. This allows us to find the width every strip is taking in that plane. So by deconstructing the box, so box corners, and D here, we have the X at its minimum and Y at its maximum, and Y being the width, we can find the here plane origin. We realign the old plane from the last point to the plane at the furthest away point. Okay, now we can pause this a bit and deconstruct here the box. I will flatten this box. And the plane origin. I've deconstructed the box. I deconstruct the domain of Y, and by subtracting the end from the start, I get the width here of every strip. And now I mass addition in order not to take the overall result, but to take here with PR the steps, and then move the plane XY on which I will be projecting the strips by vector Y of these steps. So these are where the strips here will be aligned, will be put. And now I can just orient these planes here, the strips from these planes here to the new planes. And as you can see here in top view, every strip is sitting next to the other. Now can turn off everything. In order for to cut these pieces, I just need the outline. So I will get the mesh edges and join the naked edges, and I'm good to go.